Here in these problems we have rectangular points. We want to change them into polar points, so we want to figure out what is the radius or the distance away from the origin, and then what is the corresponding angle. We're going to use the smallest positive angle. It's meaning the angle is going in the counterclockwise direction. Obviously there's many different points that we can use for the angle as well as the radius as long as they land in the spot 3, 0. So 3, 0 is just this point here on the x-axis. Clearly in terms of polar points, that's pretty easy. The radius is 3, the angle is 0, and notice that those two ordered pairs are the same, whether it's polar or rectangular. Let's just use the two formulas that we have here, so when we get to the ones that are a little more interesting, we understand what's going on here. So r squared is equal to x squared, which is 3 squared plus 0 squared, so r squared is equal to 9. So r is equal to plus or minus 3, and we'll get to that minus in a second. Tangent of theta is equal to y over x, so that's 0 over 3. So tangent of theta is equal to 0, so theta is equal to 0. So, and also theta is also equal to pi. So if we want a positive radius, it's 3, 0. And if we want a negative radius, then my angle is pi. That's the other answer I have here. And negative 3 will be the other point. And as well, if we wanted to, another way we could represent this angle is to go to negative pi, which would go in the clockwise direction. And then negative 3 will put me back on the positive x-axis. So all three of these are the same way of representing this rectangular or Cartesian point. So again, there's only one way to represent the Cartesian point 3, 0. There's many ways to represent the polar point that happens to land on the x-axis with a distance of 3 away from the origin or the pole, if we're talking about polar points. So I just did it really quick. I just did 3 different ways. But Cartesian only has one version. On your homework or quiz, it depends on what the directions are, but I think for the most part it'll just be find one point that represents the polar point that represents the Cartesian point. So we have negative 3, 3. So that's going to be over in the second quadrant, so negative 3, 3. And hopefully everybody notices that I've just drawn an isosceles, a right triangle. So the angle associated with that is 3 pi quarters. And the radius is going to be whatever 3 squared plus 3 squared is, which is 18, which is 3 radical 2. So one version would be 3 radical 2, 3 pi over 4. Let's just use these formulas here to reinforce them. So r squared is equal to negative 3 squared plus 3 squared. So r squared is equal to 9 plus 9. So r squared is equal to 18. So r equals plus or minus 3 square roots of 2. The tangent of theta is equal to 3 over negative 3, y over x. So tangent of theta is equal to negative 1. So theta is equal to, tangent is negative in the fourth quadrant. So that would be 3 pi over 4 and 7 pi over 4. So if my angle is 3 pi over 4, then my radius in this case is 3 square roots of 2. And if I use 7 pi over 4, that's over in this quadrant, but I want to make sure the point stays in the second quadrant. So that would be the negative radius of negative 3 square roots of 2. Excuse me. Let me erase that. So there you go. And I could do some more angles, but I did one other example. If I have a negative angle, if I have negative pi over 4, negative pi over 4 puts me in the fourth quadrant, but I want to be put back into the second quadrant, so that I need to have a negative radius. So that's negative 3 radical 2. I have an extra parentheses there. Sorry about that. So notice that, again, I think on the homework, on the quiz, you just need to find one point. I just went a little over the top here with all the different examples. But we have a couple more examples to do, changing from rectangular to polar points. Okay, so radical 3, negative 1. So that means I go to the right radical 3, which is in between 1 and 2, and down negative 1. So that's going to be right around here. So we draw this point and the corresponding right triangle. So using these formulas here, I don't feel like doing the Pythagorean. This is just the same thing as the Pythagorean. So this is r squared is equal to the square root of 3 squared plus -1 squared. So r squared is equal to, it's a sad looking r, which is equal to 3 plus 1, which is 4. So r squared is 4. R is plus or minus 2. The tangent of theta is going to be y over x, which is -1 over radical 3. So that's going to be a pi 6 angle when tangent is negative, which is in the second and fourth quadrant. So theta is 5 pi 6 and 11 pi 6. Excuse me, 11 pi 6. So if I want the angle to land in the fourth quadrant and the radius to be positive, that's going to be 2 and then 11 pi over 6. And I can have 5 pi over 6, and if I have 5 pi over 6, I'm going to need to have a negative radius, so that'll be -2. And I could also do negative pi over 6, which would just be 2. Here's our last example. This time we're going to be in the second quadrant again. So I'm going to go over -2 and then up to radical 3, which is going to put me right around here. I lost my point here, so that's going to put me right around there. So it's going to be a second quadrant angle. So first we need to do r squared, or figure out the radius, which is going to be -2 squared plus 2 square roots of 3 squared. So that's r squared is equal to 4 plus 4 times 3. So r squared is going to be 4 plus 12. R squared is 16. R equals plus or minus 4. The tangent of theta is y over x, which is 2 radical 3 over -2. So tangent of theta is equal to negative radical 3. So that's going to be pi 3 angles in the second and the fourth quadrant. So that's 2 pi thirds and 5 pi thirds. So since I want a second quadrant angle, I want my radius to be positive. So that'll be 4 comma 2 pi thirds. If I want to use 5 pi thirds, I'm going to need a negative radius, so that's -4, 5 pi, 5 pi over 3. And if I wanted to use a negative angle, if I went from here all the way to here, that would be -4 pi thirds, and that would be 4. So that's 3 different representations, even though it didn't say that in the directions. I felt it's appropriate to show that there's many representations for polar points where there's only one way to represent any Cartesian or rectangular point.